So today I will discuss with you the cyclic properties of circle. Cyclic properties. Cyclic properties related to circle. Let me first define the very important thing, very important terminology you will come across. Cyclic quadrilateral. Now, what is cyclic quadrilateral? Suppose there is a circle and there is a quadrilateral whose vertices lies on this circle like this. Suppose this is A, this is B, this is C, this is D. So if a quadrilateral is circumscribed by a circle, if all the vertices of the quadrilateral lie on the circle, then that quadrilateral is called cyclic quadrilateral. Now, is there some important property to remember with respect to this diagram? Yes. You must remember that angle B plus angle D, the sum of opposite angle is 180 degree, supplementary to each other. Similarly, angle A plus angle C is 180 degree. How to prove this? Very simple. You should join the center O with 2 points. Suppose I take the center O at this place. Now I'm joining this. Just a minute. Let me take the center O at this place. Now I'm joining A and C with center. This is O center. Okay, I joined A and C with center O. Now see, suppose this angle is 2 theta. Then what is the magnitude of this angle? This would be 360 degree minus 2 theta. Now everybody knows that angle made at the center is double of the angle made at the circumference by a chord. Okay. So using that principle, I can write angle B is equal to 2 theta by 2. If you take chord AC, then for chord AC, the angle made at the center is 2 theta and angle made at the circumference is theta. This angle will be theta. Okay. Now what about angle D? Similarly for angle D would be half of this angle, 360 minus 2 theta. So 360 degree minus 2 theta divided by 2. Okay, so this will be 180 degree minus theta. So we can write angle B plus angle D is theta plus 180 minus theta. In both the cases for angle B and angle D, we are applying the same fundamental theorem, or you can say fundamental rule, like angle made by a chord at the center is double the angle made by the same chord at the circumference. Okay, so this theta and theta will cancel out and angle B plus angle D would be 180 degree. Similarly, you can prove for angle A and angle C. Angle A plus angle C would also be 180 degrees. Now let's come to the second property. Now the second property is the exterior angle. This is also an important property. The exterior angle. The exterior angle of a cyclic quadrilateral. Of a cyclic quadrilateral. Is equal to the interior opposite angle. Now let me make a diagram for you. This is a circle, and suppose again I am making a cyclic quadrilateral. A, B, this is C, and this is D. Okay, so this is A, this is B, this is C, this is D, and let me extend this part. What we need to prove? We need to prove like this angle theta is equal to this angle theta. Okay, the exterior angle of a cyclic quadrilateral, this angle is exterior. Equal to the interior opposite angle. For this theta, this is interior opposite. Interior opposite. So had we been extended angle A, then the interior opposite angle would have been angle C. Let me show you. For this is the interior opposite. Okay. Now how to prove this? Let me put this point as E. Okay. So we need to prove that. We need to prove angle CBE is equal to angle ADC. Now we can see this is a cyclic quadrilateral. Hence, since ABCD is a cyclic quadrilateral, hence angle ADC plus angle ABC is equal to 180 degree. Sum of opposite angles is 180 degree. And angle ABC plus angle CBE is also 180 degree. Right? In a straight line, you know this alpha 1 plus alpha 2 is 180 degree. So same way, this angle ABC, this angle and this angle theta, the sum of these two angles is 180 degree. Hence, angle ADC plus angle ABC is equal to angle ABC plus angle CBE. These two will cancel out. So angle ADC is equal to angle CBE. So ADC is CBE. Okay. So this we needed to prove. Similarly, you can prove that angle DCB is equal to angle DAF. Suppose this point is F. Okay. So these two are very important property. There are some more properties, but they are not that much important or that much, you can say, rare, like these cyclic quadrilateral properties. So in cyclic quadrilateral, these two properties are very often asked. Like the sum of opposite angles is 180 degree, and the exterior angle of a cyclic quadrilateral is equal to interior opposite angle. If you want to revise all the properties of circle, all the the most important properties of a circle, then quickly I can recap. The third property, you can say, draw a circle, and you can imagine like the length of chord would be same if they are situated at the same distance from the center. Suppose this is O, this is A, this is B. Suppose this is MN, this is PQ. So if OA equal to OB, then Mn is equal to PQ. And these are self-explanatory. You can easily understand these things like these two are radius. Let me draw with dotted lines. Again, these two are also the same radius. So if OA equal to OB, we can easily find out with Pythagoras. like Mn is equal to PQ because these two lengths are equal. These two lengths are equal. So using Pythagoras, you can easily find. No need to explain it. Now the fourth one, you can also prove like the angle made by a chord at the circumference is half the angle made at the center. This is also very easy. What you need to do, suppose this is AB, AB is a chord, and suppose this is a C point. Just join this line, C and O. So if this is alpha, this is also alpha. If this is theta, this is also theta. Now you can understand this is alpha plus theta. Angle ACB is what? Alpha plus theta. Now extend this. Now this angle made by green and this angle by blue. This green one will be 2 alpha. Why? Because sum of interior angle is equal to exterior angle and 2 alpha is exterior for angle A and angle C. Similarly, this 2 theta is exterior angle for theta and theta. Okay, angle OCB and angle OBC. For these two angles, this blue angle 2 theta is exterior angle. So you can easily see this angle AOB is equal to 2 times alpha plus theta. Hence, angle AOB is equal to 2 times angle ACB. And in this way, you can easily prove like the fifth one, angle made in a semicircle is 90 degree. Why? This diameter is also a chord. So if this angle is 180 degree, this angle must be 90 degree, where AB is diameter. Now you can also prove angle made at the same segment are equal. Theta, theta. Why? See, chord is unique. Now this AB chord will make angle 2 theta at the center, right? So if you take this C and this D, angle ACB is equal to half into 2 theta. And also angle ADB, ADB is also on the same chord, AB is also half into 2 theta. So they both are same. Angle ACB is equal to angle ADB. There are so many properties you can prove using simple geometry, but the main two properties which you are going to use often in cyclic quadrilateral is property number 1 and property number 2. So go through these properties and be fearless about properties of circles. Okay, thank you.